Hello everyone, I am Dr. Nitin Kumar Saxena. In previous lecture on electrical charge, we have studied the theoretical aspects of electrical charge, in which we have seen what is electrical charge, what are the properties of electrical charge, what are the conservation of charge, what are the Coulomb's law, how we will define 1 coulomb, and what are the electric field lines and how the electric field moves from positive charge to negative charge. So in this class, we will try to make some better understanding of electrical charge through some conceptual problems related with electrical charge, which we have seen in our last class till so far. So first question is like, suppose I am saying that I have a body. Okay, if I have a body, maybe spherical in shape, right? And this body has plus Q charge. This body has plus Q charge. First of all, try to understand that when we have any body and the body has some charge, then charge always comes at the outer surface of the body. It will not be like this, that it will be here, no. The whole charge will come at the outer surface of the body. How can you understand this? To understand this, the same logic which we can use, that for this positive charge, what we are assuming, that negative charge is at infinity, and that in negative charge is attracting to this positive charge. And since there is what we say attraction force, then body will try to move towards the negative charge particle. And at the same time, since the body this is the conducting material, this is metallic sphere, so all the charge will flow from inside surface to the outer surface, because up to this point it is free to move. After this it is not free to move, but up to this point it is free to move. So it will always come at the outer surface, right? And now what I am doing, I am putting another sphere near to this, and I am touching both, or you can say I am connecting one metallic rod through which the flow of this charge is possible. This is also conducting nature. So this metal sphere has plus Q charge, which is at the outer surface of this sphere, right? There is one another metal which has no charge, but now what we are doing, we are connecting these two surfaces through this metallic rod, or simply by touching both these sphere. We can use any method, right? So what will happen, since now this plus Q charge is free to move again, so it will move on this sphere also, and equal charge will be distributed on both the surface, because the surface area for both these spheres are same. So what we will say, if we disconnect this two sphere sorry, so if we disconnect these two spheres, then we will say that the charge on first sphere is plus Q by 2, and charge on second sphere will be plus Q by 2, right? Now you see the same thing, I am explaining with another example. Now we have, suppose we have sphere 1, sphere B, sphere A has plus Q charge, sphere B has plus Q charge, and we are having another sphere with plus Q charge. I am not distributing uniformly on the sphere, but you can assume that this plus Q charge is distributed on the outer surface of all these spheres, right? So all these spheres A, B, C has plus Q charge, right? Now what I am doing in first case, this plus C plus Q charge, having plus Q charge, sphere C, I am going to touch with sphere A first. First C will touch to A, and then C will touch to B, right? So finally charges on A, B and C. So this is the question. Again I am repeating the question. The question is that we have three spheres, sphere A, sphere B, sphere C. All the three spheres have plus Q plus Q plus Q charge. In first case, C will touch with sphere A and then C will touch to sphere B. Then what will be the value of charge on all the three spheres A, B and C finally? So again the same concept we will apply. This plus Q, what will happen? Let me allow to change the value of this plus Q so that it would be easy to understand, right? So let me allow that I am taking this sphere C with value plus Q plus 2Q. Okay, so now when we touch this sphere C with A, now the total charge is plus Q and plus 2Q, so total charge will be plus 3Q. And now when we are separating the sphere A and sphere C, so this plus 3Q charge will be uniformly distributed on these two. So in first case you see like this is A, this is C, so this has plus 2Q, this has plus Q. So when we are, this is like this. When in second case, now when we are putting like this, so total charge will be plus 3Q, right? And now I am separating these two. In third case, when we are separating again A, C, then what will happen? This charge will be divided equally on the both these spheres. Say because I am supposing the surface area of all three spheres are same. Then plus 3Q by 2 plus 3Q by 2, right? Now the second point is, now C will touch to B. When C will touch to B, so again this is C or this is B. This has charge plus 3Q by 2. This has charge plus Q. So next step, when we will touch them, this is C, this is B. So what will happen? What will happen now? Plus 3Q by 2 plus Q. Total will be, when we will add, 5Q by 2. So this will be 5Q by 2. Is it okay? 3Q by 2 plus Q, when you will add, you will get 5Q by 2. And now you will separate B and C. So C and B, when you will separate, then what will happen? This charge will uniformly divide on C and B. So on this 5Q by 4 and on this 5Q by 4. And hence what you can see here, you can analyze that finally initially the charge initially now let me allow to rub it. Initially A, B, C plus Q plus Q plus 2Q, and finally if we do in this sequence, first C touch with A, then C touch with B, then finally the value on A is 3q by 2, on B 5q by 4, and on C 5q by 4. I hope you understand that how the charges are flowing from one sphere to second sphere and how they are dividing with each other. So after this, let's again do another problem in which I am saying, I hope it is clear to all of you. Now I am moving to the next problem. So what is next problem? Suppose I have a sphere, metallic sphere, right? A metallic shell. Okay. I have a metallic sphere and a metallic sphere, shell around it, right? Here also the same structure I'm drawing again, metallic sphere and here metallic shell. In first case, we have charge at this surface. Mean to say that in first case, the metallic sphere has plus charge, plus Q charge. Say plus Q charge, which is uniformly distributed. In second case, we have plus Q charge, which is uniformly distributed at the metallic shell, right? In first case, both are the same structure, but in first case we are assuming that charge is at this metallic sphere. In second case, we are assuming that charge is at the metallic shell. So now what I am doing, I'm connecting both the metallic body are metallic shell and metallic sphere. I'm connecting both the body through a conducting rod, right? Here also I'm connecting it through a conducting rod. This is a conducting rod, so flow of charge is possible. Charge can be flow. So what would be the answer? Whether this charge will go to this surface or it will be divided, or what will happen? Same case, what will happen here? So in previous case, we have seen that there were two bodies look like same, and like one body has some charge, and when the second body is coming in his contact, then the charge distribute. But here you see the case that one body is inside another body. Then what will happen? Here you see that this is plus Q charge, and when we connect it with this conducting rod, so you apply the first concept which I have given you, that charge always try to go on the outermost surface. Why? I told you in previous in this class, the charge always try to go on the outer surface. So what will happen? Here, when you connect this metallic sphere with this shell which is around it, so this charge will go. Where it will go? It will move from here to here. So all this charge will move from this surface to this surface, right? But when you see this, the charge is already on the outermost surface. The charge is already on the outermost surface. So it will remain at outermost surface. Whether you connect with conducting rod or not, the charge will not come back to this metallic sphere. And hence, in both the case, finally the charge will be at the outermost surface. Here it will remain. There will be no this system will not bother whether it is connecting to rod or not connecting with rod, because the charge don't want to come on the inner surface. It will remain at the outer surface. At the same time, here the charge is at the inner surface, so through this conducting rod it will come at the outer surface. So I hope you understood the concept, how the charge will go on the outer surface. Next, I'm giving you a very simple example. Suppose a body has, after this example I'm giving you another one. So what is another example? Suppose a body has 5 neutron, 7 proton and 9 electron. What I am saying, a body of metal has 5 neutron, 7 proton and 9 electron. Right? So what would be the value of overall charge on this metal? So you see, 5 neutron, 7 proton, 9 electron. Their charge is 0 because neutron does not have any charge. Okay. Here 7 protons means 7 coulomb. Right? 9 electron means minus 9 coulomb. So what is the total charge? Minus 2 coulomb. Right? And you know the value of 1 coulomb is 1.6 into 10 to the power minus 19. So the total, if it has this structure, the total charge will be 2 into 10 to the power, so 2 into 1.6 10 to the power minus 19 with negative sign. So minus 3.2 into 10 to the power 90 coulomb. Right? So in this way we can find that what would be the value of overall charge on a body. Is it fine? Now move to the another example. Suppose I am saying, if I am saying a body has 1 electron. Okay, a body has a total 1.6 into 10 to the power minus 19 coulomb charge. Right? What I am saying, I am saying that a body has, okay, let me allow to write this question first, then you will be able to understand it. What I am saying, that a body has total 1 coulomb charge. If it is transferring 1 electron per second, what would be the total time to transfer the whole charge from the body? Okay, so what I'm saying, we have a body and body has total charge is 1 coulomb and the body is transferring 1 electron per second. So what would be the total time after which the body will transfer its whole charge? So it's a very simple question. You can solve it by unitary method. What is unitary method? That you know that the 1 electron charge is 1.6 into 10 to the power minus 19 coulomb, right? So 1.6 10 to the power minus 19 coulomb charge is being transferred in 1 second. So 1 coulomb charge will transfer in 1 divided by 1.6 10 to the power minus 19 second, right? If you want to make this second in minutes, what you will do? 1 upon, or you can shift this 10 to the power 19 there, 1.6 into 1 upon 60 minute, right? Now I want to make it in hours, then 10 to the power 19 upon 1.6 into 1 upon 60 into 1 upon 60, this will be hour, right? Because 1 hour has 60 minutes and 1 minute has 60 seconds, right? So to transfer 1 coulomb charge, the system will take so much hour. I hope you see this 10 to the power 19 is a very big quantity. So when you will solve it, this value will be very large. And like if you want again to make it in days, so how can you make in days? 10 to the power 19 divided by 1.6, 1 upon 60, 1 upon 60. This is an hour. 1 day has 24 hours. So when you divide again by 24, so now it will be in day. Now it will be again in day. And again, if I say you want be in air, so if you want this in air, so again what you will do? You will divide it by you want to make this day in air. 1 year has 365 days. So you will again divide it with 365. So it will be in year. And when you will solve it, the answer, I'm telling you, the answer is 198 year. So you can see that if you are transferring one electron in a second and you have total charge 1 coulomb, so to transfer this 1 coulomb charge with the rate of 1 electron per second, how much time you require to transfer the whole charge from this metal or from this body? 198 year. So I'm again repeating, how did I get this value? So again I'm repeating for you. See, one electron has the value 1.6 into 10 to the power minus 19 coulomb. So this means if we are transferring one electron in 1 second, we are transferring 1.6 into 10 to the power 19 coulomb charge in 1 second. So 1 coulomb can be transferred naturally 1 divided by 1.6 into 10 to the power minus 19. That's a unitary problem. You all have done unitary problems in your class 6 and I think. So now this is in seconds and now I want to make this seconds in minutes. So what I will do, I know 1 minute is 60 seconds. So I will divide the whole expression by 60. Now this is in minute. Again I am dividing it by 60 because 1 hour equals to 60 minutes. So now it will minute convert in hour. Now since this is in hour and 1 day has 24 hours, so again I will divide by 24, so it will come in days. And I want to make years, so 1 year has 365 days, so again I will divide by 365, so finally I will get 198 years. I hope you have understood. And in this way, I am giving you only example that you want to transfer only 1 coulomb, you can transfer any quantity. So that depends on the example, what quantity is given to you. So according to the quantity, you can move on, right? Now next point is that okay, the last conceptual problem which I am going to give you in this lecture is like I have 2 points. Suppose plus point charge, okay, and they are placed with each other at some place. Now naturally I told you that every charged particle creates its own electric fields, and since we have 2 electric charged particles, so we have the electric fields for both the charged particles. So these electric fields, since vector in nature, so at some place they will give more electric field where the electric fields of both will be in additive nature. At some place the total electric field will be less where the electric field from 1, from 2, it's of subtractive nature. So if I design a problem that we have 2 charged particles, they are placed with each other, and I want to see at some points what would be the value of electric field, and I don't want to calculate the magnitude that we will do later on. I just want to see that at which point the value will be more, at which point the value will be less. So let us design this problem first on board and then we will try to find the answer. Okay, so now suppose I have this plus Q charge, this plus Q charge, this is something I'm making like this. Okay, this is plus Q charge, point charge. I'm taking only the point charge. Okay, this circle does not mean the body. This arm for showing this plus Q, and this small dot shows the point charge. If you are confusing, then you can remove it. It will be better. So what I am saying, we have 1 point charge here plus Q and 1 point charge plus Q, right? So for your better understanding, I am making this with black dot, right? So we have 2 point charge plus Q, and I'm making 3 different points. 1 point somewhere here, second point somewhere between these two, and third point somewhere here. Suppose I am saying this is A, this is B, this is C, right? So the question I am repeating again, we have 2 plus Q charge, point charge, and since we have point charge, so they will create their own electric fields, and then they will create their own electric field. Then due to 2 electric field, we will get some superposition. Superposition means that overall electric field at all the points. And now I want to know from these 3 points A, B, C, what would be the electric field strength at point A, at point B, and at point C. So if I have only, let's see, if I have only 1 point charge. So for 1 point charge, I have shown you that the electric field lines go radially, right? It's straight, something like this. If I have this point charge, so lines will go like this, because it is a plus Q, so it will go from the point charge away towards infinity, right? Now in this case, we have 2 plus Q charge. So naturally, the electric field lines will try to superimpose with each other, and the important point is, you must keep in mind always that no electric field lines cut to each other. Okay, these electric field lines will not cut to each other. What we will get at every point, it will be like not like this, that if I am saying okay, 1 plus Q is coming here and second minus Q is coming here, so it will go like this. No, we will get the superposition, and the overall superposition will be act only in one particular direction, right? So this means, if you see this example, so what you will say, that electric field lines, so electrical field lines at plus Q and this point charge and this point charge, we can draw like this. From here we see that electrical field lines for this will be radial only, but because of this it would be something curved in shape. Okay, they would be in curved shape. And if you see that if they are in curved shape and the lines which are trying to go out towards this charge, they will be repelled. And if they will be repelled, they will go like this. In a similar case, if you go for this plus Q charge, the same, all electrical field lines will go like this. And the lines, electrical field lines, which are trying to go towards this point charge, they will be repelled through this, and hence they will not go beyond this. So in this way we can see that the electrical field lines generated by this point charge will remain towards this side, and plus due to this point charge will remain towards this side. And therefore, if we talk about the point B, which lies between these two point charges, so the contribution of this electrical field lines as well as from this electrical field lines will be 0, and therefore there we at the midpoint we will get no electrical field lines. Okay, now you see the point A is very near to this point charge, while point C is comparatively is far away from this point charge. So what will happen now? You know that when we talk about any point charge, the electrical field lines go like this, and if I draw any circle here, so you see the density of electrical field lines at this particular point which lies on this circle will be more. If we are increasing the size of this circle, then you see the all electrical field lines are spreading, and since they are spreading, so after some time you see here after some distance the density will go less, and hence we can say as we move on away from this point charge, the electrical field intensity, the value of the electrical field will go down as we move away from this point charge. You see here, this point A is comparatively closer to this point charge, while this point C is comparatively far from this point charge. So what we can conclude? We can conclude that electrical field lines at A will be more compared to the electrical field lines at C. And when we compare between A and C, what we will get? That the electrical field lines at A are more compared to the electrical field lines are at C. And at B, the electrical field lines are very less, or approximately, if it is exactly at the midpoint between the line joining to these two point charges, so we can say the value is 0. So we will say that the value at B will be the least. So if we compare, then electrical field at A is more than C, and electrical field at C is more than at B. So in this way we can analyze that if we have more than one point charge, what will be the effect of electric field lines at different places. So friends, we stop this lecture on this point. We have seen the several type of examples which use the concepts of electrical charges. I hope you enjoyed this lecture. Thank you very much.